Well, what are we going to do for our next great adventure? Well, here's what we're going to do. I'm going to take the tuner that this schematic belongs to and try to figure out what's wrong. So what we have is a Fisher Model 202R, and it's one of those ones that can do the I forget what they call it, where they use the AM for one channel and the FM for the other channel, and you can get stereo. They did that for a very short time in the I believe it was in the early 50s, and this is one of those tuners. It's really nice. These are pretty well built, but this one's got some issues, and I think it might be a little bit of a challenge to troubleshoot. So I thought it would be fun to put it up on a bench and try to repair it. So if that sounds interesting to you, stay tuned, because that's what we're going to do. Okay, so here it is, the 202R, and it's in pretty good condition for what it is, you know, how old it is. When I got this has been sitting down here for, I don't know, a year or better. I don't know. I plugged it in, turned it on, and the AM, if I recall correctly, the AM worked. FM didn't work at all, and I think it was one of those local oscillator things, possibly. I don't know. At the time, I didn't have the service documentation. I since have gone and found it and downloaded it, printed it out. So hopefully we can use the schematics here to find out what's going on. Okay, looking at the rear of this thing, you can see it's a little different than a lot of tuners that you see out there. It does have a distance and local switch. That's not anything crazy. Instead of having just separate terminals for 300 ohms and 75 ohms, there's actually a switch. So you can switch back and forth for balanced and unbalanced antennas. Micro tune, I'll have to refresh my memory on what that is, but I think what that is it's kind of like an AFC circuit, if I'm not mistaken. I could be wrong. I'm sure you'll correct me, any of you that know that. These are your output levels for the AM and the FM, and that was important back in the day, because if you were doing, it wasn't called binaural, but I forget what it was called, but if you were doing AM, FM stereo, you had one channel on AM, one channel on FM, you would have to balance the outputs, because each station that you're tuning in separately for the two channels could be different signal levels. So you could have a very, a loud left channel and a quiet right channel. So you would adjust these to balance that out. And you can see the FM or the AM comes out of this channel and the FM comes out of this channel. So you're only going to hear, if you're using just AM or just FM, you're only going to hear it in mono, and you're going to only hear it on one channel of a stereo amp, unless you put a splitter or something like that on there. In addition, this did have an output for the multiplex, and this might be a good place to check the oscillator circuit to see if it's working. We can see if we're getting any kind of IF out of there, which I think that was the problem. We weren't getting any IF on the FM. Okay, I have the AM turned on. I'm not getting anything but 60 cycle hum for the AM when I use my antenna. There's something in here that's majorly interfering. It's probably some lights or something. So I hooked it up to the SG80 signal generator, and you can hear I can get a signal. It's a weak signal considering the amount of RF I'm pumping into it. So there's definitely something wrong, and all of the controls here are very, you can see, really bad. And these tubes here, tube sockets are dirty, so we're going to need to do basic maintenance to this. But if we switch over to FM, you don't get anything. I mean, it is completely, there's nothing. I get a little bit of click when I go between microtune and AFC, but other than that, nothing else. Well, as you can already see, that this has signs of having already been serviced. All these electrolytics, those do not look original to the tuner. Everything else looks mostly original. Doesn't appear, it looks like these resistors have been replaced coming from the bridge. This is one of those selenium bridge rectifiers, and pretty much comes right off of the mains and goes into here. Oh, I see. So one end goes to the, okay, these are the AC. So this red, I don't know if you can see that or not, but the two red wires come from the transformer. The ground, or the negative, goes to ground and also to this resistor. And then you have on the other end of the mains fuse going into the power transformer, and then the other end goes through the switch, the power switch, to the other cord. Now, cord's been replaced, and like I said, all these blue caps here, these electrolytics have been replaced, and some work has been done on a power supply. So let's take a look at the schematic and see what's going on. So the first thing we want to check is this multiplex output. And I should get some sort of an output. Or I could just put my scope on there now that I have this open. I can use a probe. Maybe I'll do that. Okay, putting the scope on this, you can see there's nothing but 60 cycle hum on the multiplex output. So there's no IF, which is what I kind of suspected. So let's go and look at some of the voltages. I would think that the power supply is mostly good because the AM pretty much works. And it uses the same power supply for both. So we could have a problem with a tube socket or a connection, or we could have something wrong with with the IF somewhere. We could have silver mica disease because these are those, these are those IF cans that are prone to that. And I wouldn't be surprised if we find something like that. Okay, so looking at test point 1, that's where your local oscillator is. You should be able to see your modulated 10.7, and you should be able to see the audio there riding on top of your carrier. And in fact, when I connect the scope to TP1, which is this wire hanging down here, I have, there it is, I have a 400 hertz modulation going in, FM modulation. And if I change it to 1 kilohertz, it changes to 1 kilohertz. So we are getting a signal through there. So I need to trace it through and see if it goes, it is coming out of the local oscillator. So if I go into my IF, which is down here, so let's move from here. So you have your first IF and your second IF. If I go down to here, I should be able to see it. And I'm like off the scale now. The whole screen's lit up. This has to do with the digital scope, the sample rate and so forth. And you can see right there, there's our modulation. And I don't have, you can see I can turn it up. So there's 99% modulation. There's 90. So that's working. I go to 1 kilohertz, 400 hertz. So it is coming through there. So let's come out of there and go to the next one. I believe that goes down here. And you can see that signal really, really goes downhill right there. So I'm wondering, maybe there's something going on with that tube, because you saw how much amplitude I had. So just going from, let's go, from this IF, let's see where I'm at, this one up here, and then I come out of here, you get a little tiny signal there, which I would expect, because it's going through that can, which might be a bad transformer. And then I got a tiny little signal coming out of here. That just doesn't seem right to me, unless I'm on the wrong side. I'm not. That is the correct one. Yeah, it's very attenuated. So right there is, I think, where we're losing our signal. So that's between the second and third IF, which is, let's see here, if I'm doing this right, or the input and the output of the second IF, I should say. So there's something going on with the second IF. It's not working. Okay, I think we're getting somewhere now. So let's back up one stage. If I go to our second IF tube, the output of it, which is right up here, and that's on this, what is it, V5. Sorry, that's the third IF tube. The input of the third IF, the output of the second IF. See where I put the scope? Down here, I'm sorry. Right there. And you can see I have a pretty good signal. Now if I take my probe off of V5 input, go to V5's output, which is going to be right, well, the input to V6, I still have a good signal. I come out of V6 right here, which goes into the IF transformer. I have a total flat line. And when I touch the vacuum tube, touch the actual tube, it is absolutely ice cold. V6 is really hot. I mean, it's hot. Not like grid leakage hot, you know, but it's hot. But the other one, I mean, it is absolutely ice cold. It's like there's no filament. So let's pull the tube first. We'll see if it's good. And if it's good, well, we can even look at the filament to see if there's an input to the filament. The filament on those, which is V, it's going to be pins 3 and 4. So let's go down here and we'll look at pins 3 and 4. See if I can get everything in shot for you. Looking down here, pins 2, yeah, there's 3 and 4. So let me get here and see if I can hold this on here, and you can tell me what you see on the meter. And then I can go to the other pin, which is pin 3. Yeah, I got 6 point, right there you can see we have 6.3 volts. If I can hold the meter on, see it? 6.5. So I have filament voltage to the socket, but the tube is ice cold. So let's see if we have a bad tube. So I'll shut this off. I'll pull this tube out. I mean, it is absolutely ice cold. These are all Mullard, Great Britain Mullard tubes. Pretty impressive. So let's just do quick and dirty ohms test and see if we have a filament here. 1, 2, there's pin 3, pin 4. Yep. So the filament is good, and the tube's not getting warm. But let's just make sure it has emissions. So let's grab a tube tester. I have my send core down here. Okay, I have the dial set. Let me turn this on to grid leakage. Yeah, you should do the shorts test first, but I'm going to skip ahead here. I don't see any kind of grid leakage. Yep, the filament is lit. We have a filament. So let's go to emissions. We have good emissions. So it tells me there's probably something wrong with the socket. So let me flip this thing around and let's look at the socket and make sure it's okay. Okay, here's the one that was getting hot. This was the one that was ice cold right here. Looking at the socket, it doesn't really look too bad. You can try cleaning it a little bit, but I don't think that's going to do it. So I don't know. It might just be just an overall bad socket. But you can take a little pin here, a little thin screwdriver or something. You can kind of go around these and pinch them in a little bit. I mean, it's possible that one of these are loose, but they sure don't look it from up here. You really don't have to give too much force to them. These are decent sockets. They're not the best. They're made out of that, what are that, Formica or whatever the heck they make them out of. Wafer stuff that they make deck switches out of. And but these ones are the thick ones. They're layered, and they're typically pretty reliable. I mean, these have pins that go all the way around. They pinch on both sides, and I don't know, I just don't see how that could be causing the problem, but hey, who knows. Let's spray a little bit of cleaner down in there. I'm just going to put a little tiny bit of contact cleaner. This is not deoxit. Don't ever spray deoxit in these pins. You want to just spray something that's no residue, that's going to evaporate. You don't want to leave any kind of oily substance behind on these pins because they get hot. And will kind of heat up that oily stuff, and it'll make a big gunky mess in there, and it'll just really cause those pins to have problems. So that's not where you would put a contact lubricant. You want to put a contact cleaner only. All right. And of course these pins are nice and clean. No problem with those. I mean, obviously they're clean enough because they worked in the tube tester. So let's plug this back in. That felt pretty good there. I'm going to leave these two covers off. Okay, so let's back some things up here so I can flip this back up.
Looking around this room.
Yeah, it's working. Not picking a lot up tonight, but of course. It's working. Yep, we're good. Okay, I am a little bit less tired and punchy today. After a 3-day trip, 700 miles of driving, and 5 different locations, multiple service calls, I'm home, and pretty much recovered from that now. So I am ready to get back to work. So I know what you're all going to say. I know you're going to say. You're ready to say it, aren't you? Your fingers are on the keyboard right now. You're saying, Tony, aren't you going to align that tuner? Please align the tuner. You're not showing us how to align the tuner. So you all want me to align the tuner? You want me to align the tuner? Yeah? Yeah, let's align the tuner, okay? I'm going to align the tuner. Very good. Okay, I have the 2 safety caps installed here and here, and I also have replaced that film, or the foil paper cap with a Mylar capacitor. So we're good now. And to start off, we're going to do the AM alignment. The service manual is not really good on this one. This is not a beginner's receiver to do an alignment on. One of the problems is they don't have a component layout photograph. Normally there would be a photograph that tells you, what each component is and where it's located on the chassis. This service manual doesn't come with that. Second of all, if you look at the schematic, you'll see all of the, indicators like R32, C53, all those things. But if you notice, nowhere do they show you the values of those components. In order to know those values, you have to print out the parts description list, and then you have to look it up and look at the value, and then go here based on the schematic. They do have a tube layout chart, and that's the only thing you get. It doesn't tell you where the IF cans are, or any of the adjustment transformers. None of that, none of the coils, anything. It only shows you the tubes, but at least that'll give you a general idea. So you locate the tube that you want to work on based on the schematic. You locate it in here, and then look up the components, and you got to kind of figure out where you're going to connect things. The service manual has kind of an maybe unconventional today. It wasn't so unconventional back then. But you need some special equipment to do the alignment the way they want to. First of all, this has adjustable bandwidth, meaning you can have it have a wide bandwidth and narrow bandwidth. There's 4 different settings. And what that does is that allows you to get high fidelity audio, or as close to such as you can on AM. And the reason is this thing can do simulcast. It was designed to receive one channel on AM and the other channel on FM, and it would be stereo. Well, of course, FM will outperform AM when it comes to audio because it has a wider audio bandwidth. So what they do on this is they maximize the amount of bandwidth you can get. AM radio stations are spaced 20 kilohertz apart from one another, so that doesn't give you much bandwidth to have sound. So most of them are cropped off around 8 kilohertz, 5 to 8 kilohertz. So you want to maximize that, and that's what that bandwidth switch is all about. In order to get this all to work properly, though, you have to make a couple of adjustments that you don't normally do on a regular AM tuner. The first one that we're going to do is we're going to adjust the 10 kilohertz trap, or the 10 kilohertz filter. What is that, you might say? Well, looking at the schematic, and I'll get the bigger one out here so it's easier to see. These 3 components here, you have a capacitor in parallel with an adjustable capacitor, and then you have those in series with a coil, with an inductor. And this is a type of notch filter. What it's doing is anything in the 10 kilohertz range, it's going to cut off. Why 10 kilohertz? Well, the center of your channel is going to be centered in between that 20 kilohertz range. So for instance, if all your AM stations are 20 kilohertz apart, if the band edges are, let's say, 900 and 920 AM, 910 would be the center of that bandwidth. So that's where your carrier would be. And then your side bands cannot overlap. They can't be any more than 10 kilohertz wide. And so by putting this filter on here, if there's an adjacent channel that has excess noise that's kind of spilling over into your bandwidth, this will prevent that from interfering. So basically, it keeps your bandwidth within 10 kilohertz of the center frequency on either side. Usually it's just a circuit that they put in there, fixed components. But this one actually lets you adjust it. Now, the way they have you do it is they want you to take like a 1 volt, really high power signal, and they want you to inject it right into this this diode, because these are diodes down here, these two things. And that's going to be your detector diode, and they want you to inject it right in pin 7, and they want you to put a 10 kilohertz signal, and then they want you to look at the output of the, where the speaker would be, and just adjust for minimum overall signal. The problem is if you have a noisy basement and you pick up a lot of static and so forth, it gets really hard to sort that out. So what I've done is I removed the RF amplifier. So that's kind of going to get rid of the radio stations for the most part. I then went to the first IF and I injected a 455 kilohertz signal, and I'm going to modulate it with a 10 kilohertz signal. Now most AM, FM, RF, signal generators are not capable of an internal 10 kilohertz modulation, so you have to use an external. So that's what I have over here. I'm set to 455, which is your IF frequency. I'm injecting a 10 kilohertz signal from up here, the DG4162. I'm just taking 10 kilohertz, feeding it right into there. Then I have my 455 carrier with a 10 kilohertz modulation coming out of there, and I'm feeding it, as I said, into the first IF, which is this V15, right into pin 1. And that's where that is there. So what that's going to do is that's going to push a 10 kilohertz signal all the way through the IF and all the way through the AF and out to your output terminals. And you can see there it is right there. It's already pretty tiny. The idea is we want to adjust that trimmer pad. So this one right here, we want to adjust this until we completely extinguish that altogether. So that's what we're going to do. So you can see at 10 kilohertz, there's a little bit of signal there. Now watch as I adjust the pattern, and that pretty much takes it out. So that's gone now. Now here's the thing. As I go down in frequency, so I have a 10 kilohertz modulation, 9, and you can see it's starting to come in, 8, 7 kilohertz, 6, 5, now you have some pretty good amplitude, 4 kilohertz, 3, 2, 1, and you can see at 1 kilohertz there's a lot of amplitude there. And that's what that filter does. So by its very nature, and we're on sharp right now. Now if we go to wide bandwidth, what happens is as I go to 10 kilohertz, it's still mostly gone, but it's there. You can see it. And you really don't want, and you can see I can adjust this, and it just kind of squelches it out somewhat. And that's all we can do. And if I go to wide, it's mostly gone. So those are the different bandwidths. Just showing you, let's see if I can do this without trashing everything. What I'm talking about here is you can see AM bandwidth, sharp, medium, wide, and ultra wide. So as I go to the sharp, that's where they want you to adjust this. Actually, they want you to adjust it on wide. And if I go to sharp, it'll completely take it out. So let me show you what I'm talking about, how bandwidth works. So let's go to 8 kilohertz. And you can see that signal there. And you can see it's still attenuated. But if I go to ultra wide, see that? And if I go just up 2 more kilohertz, it's gone. You see how that trap works? So really, you're not going to hear anything over about 8 or around 9 kilohertz when it's on ultra wide. And when you're on narrow bandwidth, I'm at 9 kilohertz, 8, 7, 6. You don't start hearing it till about 5 kilohertz. So if you want to just listen to speech, you would set your AM bandwidth to sharp. It'll get rid of all the adjacent noise. It'll make it quieter, but you have a lower frequency response. You have less frequency response. Hope that makes sense. But that's the first thing you want to do, is you want to get that trap set properly. Okay, now we're ready to do the IF alignment. And in order to do that, we're just going to stay connected the way we are at the front of the IF strip. By the way, this jumper that I have in there, I don't know if I explained that. All that's doing is I'm jumpering C31 to ground. In other words, this line here between R8, C31, and R21, you see that junction? We're going to jumper that directly to ground. And that's going to take out the AGC circuit. So that the AGC isn't fighting with us when we're trying to align the IF. That's all that is. That's what this jumper is here. And that's where it's connected. I still have the RF amplifier tube out. Okay, for the IF alignment, we're going to change it up a little bit. We're going to move, I've tacked a 1 nanofarad capacitor onto pin 1, or I'm sorry, pin 7 of the mixer chip, or the mixer oscillator tube. So essentially, I'm feeding my 455 kilohertz right there. And then I'm going to peak these 3 coils. So it's going to be Z9, Z10, and Z11. And they each have 2 slugs, and a top and a bottom. And we're going to set them for peak amplitude. So although you can look at this on your scope and peak it from the scope, it's really hard because you want the tiniest signal you can get and still get your sine wave to get through out into the audio. And so it's a little bit easier to use a VTVM or a analog meter, so you can kind of see that needle as you peak it. So what I'm going to do is I'm going to use a tool that just kind of looks like a screwdriver, because that's the type of slugs in this tuner. And Z9, Z10, and Z11 are the 3 here. And I'm going to just adjust them for peak. So you can see here, this is jumping around, and I can move this. And there I've gone through the peak. I'm going to come back. You can see I'm through it again. So right about there is where it is. Okay. And you're picking up some static because I have a very weak signal right now. Okay. So now I'm going to go around to the top of the coil. And it's probably pretty close. Yep. I'll go the one way. That one was peaked. Right on. Okay, so now we're going to do this one. Just watch the meter as we go. And see that one was a little bit, got a little bit more out of that. Right there seems to be the best spot. And then I'll go to the top of that coil. That one's a little bit tight. Doesn't want to move. Let me see here. I don't want to force it. There we go. Right there. So that one was pretty much peaked also. And then last but not least, we're going to do Z11. And this is just a preliminary for Z11. There's 2 alignments for Z11. I'll talk about that here in a minute once we get this peaked. First thing we want to do is get it peaked. Ooh, that one had some, look at that. Okay, looks like we're through it. Right about there. Looks like it. Let's go back to the front again. And we may actually have thrown this out of alignment by just peaking it like this, but I'll explain that here in a minute. Okay, so that's the IF, and it's peaked. And we got a little bit more out of that last coil. The first two were good, but that one, there may be a reason for that, and I'll explain it next. Okay, for the next adjustment, this is for the wideband, and we're going to readjust the T11 transformer, or Z11, whatever they call it. And what we're going to do is I'm going to inject, again, into pin 7, I'm going to inject a swept signal. And I'm going to have to use my Rigel DG4162 because I do not have my other signal generator out with the sweep generator. I only have one sweep generator that'll go down to 455, and that's the RCA WR50. And most TV FM signal sweep generators will not go down to 455 kilohertz. And that's the problem you're going to run into. So you'll have to have either a thing called a genoscope, which those are very rare to find, or a sweep generator that'll go down there. I'm going to use my function generator because it has a sweep function in it, and the only issue is I can't get the signal low enough to work properly. So what I had to do is I had to put a 20 dB attenuator, and that's a thing that looks kind of like this. It basically takes the signal coming out of your signal generator and attenuates it down by however many dB. Like this one is a 10 dB attenuator. I had to put a 20 dB in there to get it. If you're using a function generator, unfortunately, they don't have as low of an output as a RF signal generator. All these things are, I've gotten into this with other signal generator videos. But if you look at the signal on here, it kind of looks like a mess right now. And you can hear it. You can kind of hear the 60 cycle hum, but not quite. And I have the sweep set to, the center frequency is 455 kilohertz. The span is 20 kilohertz. And then I have the sweep return time to 0, and I have the sweep length to 16.7 milliseconds, which is going to give you your 60 hertz. Similar, so we're just simulating an old school sweep generator. Now, as you can see, that doesn't look right. What you should see is you should see a pretty nice symmetrical S there, and you're really not getting that. And I can't overdrive this any further or it will start to distort the, the IF section. So it's going to be kind of snowy like this, but bear with me. This is the way we had it peaked. And you can see it might work at 455, but it sure doesn't like that swept signal. So if I go and I adjust, let's see if I can get everything in here in the view, and I adjust Z11, you can see what's going to happen is I can straighten this out. See that? I didn't move it very much, but see how it straightened that out a little bit? Now I'm going to go on this side, and this, I've never tried on one of these before, and you can see just barely touching it, look what that does. That starts giving us, and I'm pretty much, that's as far as I can adjust this for now. Right there. Okay. So I'm going to take that back a little bit. Right there. Now I'm going to go back to the front, and I'm going to adjust it this way. The idea is you want a nice slope there. Now if I did this right, and again, this is an experiment, right about there. If I did this right, by making that waveform, we should be able to get really good audio when we're in the wideband. So we're at a point now that we can actually try this thing out and see if we can tune in a station and see what it sounds like. Okay, so here's the scenario. I'm using the SG80. This is just a demo for you guys. I don't need this, but for all of you. I have the RF modulated. Okay, so it's just acting like its own radio station. I'm using external input, and I'm coming from my music player, and we're going to play our Stranger Danger song, and we're going to modulate it into 1100 AM. And all I'm using right now, and I will turn this down because it's noisy, is this loop. So I'm just radiating it into the antenna, to the bar antenna. So if I go over here and show you, right over here is the antenna. You can kind of see it there. I'll hang this over it so it'll couple up. And I'll turn the volume up on the amplifier. And I'm tuned into 1100 AM. And if I start the song, and I can just tune it in a little bit. There you go. Sounds pretty good for AM radio, I think. Now, if we go ahead and we adjust the bandwidth, I'm on ultra wide. Watch when I go down. That's wide. That's medium. And that's narrow, sharp bandwidth. And there's all the way up again. Not bad. And you can see the audio on the scope. So the tuner is working really well on AM. And the dial accuracy is perfect, so I'm not going to have to adjust that. But if I did have to adjust it, you would just go to the tuning gang, which is this one right here. And there are some tuning capacitors for the, I believe, the upper part of the band. And for the lower part of the band, you have the coils you adjust. And you just go back and forth until you line it up, you know, to the dial pointer. But since it's okay, I'm not going to have to mess with it at all. So we're going to leave that alone. And there you go. Now, I can take this also off of here, and I can just plug it right into my outside antenna. You can see it there. This is a shortwave antenna, so it's really not good for medium wave, you know, AM broadcast, but it works. And we can see if we can bring in any external stations. Kind of noisy down here. There's a station.
What Hillary Clinton said last night.
Presbyterian says you shouldn't say that. You don't know his heart.
That we're seeing with the Haitian.
1-800-433-8577. 1-800-433-8577.
So there you go. So it tunes in really well. And all I've done was I just plugged in this loop right here to the antenna jack and just kind of threw it over top of the bar antenna. And you can see it's pulling in all those, picking up all those stations. So the receiver is working great on AM. And it has good bandwidth now. It sounds good. The audio is nice and clear. I think we're ready to go to the FM now.